Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In this class, we will discuss how to derive strain in case of thin cylinder. So, as here is our thin cylinder, take this length as L. So, in case of thin cylinder, as it is closed with high pressure fluid, so the inside pressure we will take as length is what L, and inside pressure we will take it as small p. As it is consist of metal, so this thickness, this small thickness, we will take it as T. Okay, so what another parts here? This inside diameter will be small t. In our previous classes, we have already calculated our hoop stress and longitudinal stress. So, we know the formula for hoop stress. Also, what circumferential stress, we will take it as sigma c, that will be PD upon 2T. And our longitudinal stress as sigma L, that will be our PD upon 4T. So, we have already derived these formulas, these hoop stress and longitudinal stress. You have not visited, then you can visit our previous videos. So, here we have that our hoop stress. So, when stress arises, there will be some strain. What is strain? Strain is our change in diameter with original diameter for circumferential stress. And due to longitudinal stress, what happens? Change in length with respect to original length. So, first we will calculate what? Our hoop strain. It will be denoted by EC. As we are taking sigma C as hoop stress, so we will take it as EC. So, EC is what? Change in diameter upon original diameter. Right? So, how change in diameter and original diameter will happen? We have already discussed that in case of hoop stress, what will change? Hoop stress will be on what? Circumference of the structure. So, it will affect our radius and radial structures. So, in case of hoop stress, there will be change in diameter upon original. We will take this change in diameter as del D upon D. So, we can write EC as sigma C upon E minus, as in case of hoop stress, one is tensile, so another one will be compressive in nature. So, longitudinal strain will be compressive. So, we can write M by E. We can take small m by E. We have already know the formula for sigma C and sigma L. So, we will put it as PD upon 2T E minus PD upon 4T E into M, right? So, next is our what? We can take common as PD upon 2T E. So, it will be 1 minus 1 by 2 m. 1 by m is nothing but what? Your Poisson's ratio, that is mu. Okay. Okay. So we have got our formula. What? We can write it EC equals to, we can take it as what? PD upon 2T. What? Our circumferential stress. Sigma C upon E into 1 minus 1 by 2 or mu by 2. Right? So, we have our hoop strain or strain due to hoop stress. Next, we will find out what? Our longitudinal strain. So, we will term it as EL, E suffix L, right? So, what we need for to find out the longitudinal strain? We will need del L by L. So, we can write formula is del L upon L. So, in case of longitudinal stress, when if longitudinally stress is applied, so what will affect? Our tensile force is in longitudinal direction. So, compressive force is in circumferential direction. So, we can write it as EL equals to what? Sigma L upon E minus sigma C upon E into mu. Now, by putting the formula of sigma L and sigma C, we will get our values. Sorry, mu no. It will be our m. As 1 by m is our 1 by, sorry, mu. Mu is what? Mu is our Poisson's ratio. So, here also we can take common as PD upon 2TE. What will left? 1 by 2 minus 1 by m. Also we can write it as EL as PD upon 2TE 1 by 2 minus mu. So, this term will be what? Our circumferential stress. We can write it sigma C upon E 1 by 2 minus mu. Right? Right or wrong? Okay. So, we have already calculated our longitudinal strain and hoop strain. Next is our volumetric strain. We can write it as EV. Okay. So, volumetric strain is what? We will subtract final volume minus initial volume. Here is your thin cylinder. So, in case of thin cylinder, what is the volume formula for volume? So, we can write pi by 4 upon d square into total length, right? Pi by 4 d square is why, as also the formula is pi by 2 r square. So we know that r is our d by 2 pi r square, sorry. The formula for area as what? We can also write, if radius is given, we can also write pi r square into L. We can write these two formulas, okay? So we have pi by 4 d square L as initial volume. So what will be our final volume? So we can write df as final diameter and our dl as final length. So our initial length will be d and initial diameter. Right. Right. So we have these values. In case of calculation of final volume, what will happen? So our final diameter will be, we can write d plus df, right? And final length as L plus del L, or dl also you can write, but del L. Okay. As okay. So L plus del L is our final length, and d plus, also we can for easy we will write it as what? D plus del D. Now we have our final diameter and length. So now we will solve del V by V as what? First we will solve this. Okay. So in our next page we will solve it. Volume is equals to pi by 4 d square into L. So our final volume will be plus del D square L plus del L, right? In case of final volume, what we have written? D plus, in case of D, we have written D plus del D, okay? And in case of length, we have written L plus del L. Minus what? Minus pi by 4 d square L in our initial volume. So now we will solve this equation. Here d plus del D the whole square. We will put the formula for a plus b whole square. D square plus del D square plus 2 into D into del D, right? minus pi by 4 d square into L. We are calculating what? Our del V. Okay, del V is our what? Change in volume. So now multiplying this with this, into L plus pi by 4 d square into del L plus pi by 4 del d square into L plus what? Del d square with del L. Del d square with del L. Okay. Now plus pi by 4 into with this term 2 into d into del d into L plus pi by 4 into 2 into d into del d into what? Del L. Okay. Now till now we have calculated only what? This part, right? Next, what? This term minus pi by 4 d square into L. Okay. We need to focus. What? Now we can cancel this term with this term. Okay. So as we already know, del D and del L are very small, very minute. So we will neglect where del D is present. So here del D square into L. So we will neglect this term. Here we will neglect this term. As here D and L are both are present, we will not neglect that. Okay. Also here we will neglect, we can write it also, neglecting very small values like del D and del L. Okay. So now what we will have? What we left? So del V is here. What? Pi by 4 d square into del L next is what? We have this term and this term pi by 4 into 2d del D into L. Plus pi by 4 into 2 into del D what? 2 into d into del D into L. D into L, right? So we can write it sequence wise like pi by 4 d square into del L plus 2 into pi by 4 into del D into D into L, right? So till now we have our change in volume. So now to calculate our volumetric strain, what is the formula? Change in volume divided by total volume. So we can write pi by 4 d square into del L plus 2 into pi by 4 del D into L upon pi by 4 D square into L. Now, what do you have? We will what? Take this term and this term. Okay. So, okay, by using another color, right? It will be more interesting. We can write pi by 4 D square del L upon pi by 4 D square into L, right? Also, what? Two into pi by 4 del D into D into L upon pi by 4 into D square into L, right? So, what we will get now? We can cancel pi by 4 with pi by 4. This D square with D square, right? Here, pi by 4 with pi by 4, L with L, D with this D. So, what we left? Del L upon L plus 2 into del D upon D. Since we still have our what? Longitudinal strain and here circumferential strain, right? Our longitudinal strain is what? Del L upon L. We can write it sigma L, EL. Yeah. We can write EL plus 2 into del D upon D is what? Our change in circumferential strain. Okay. So, still we have calculated our EV as EL plus 2 into EC. What are those EV, EL, EC? EV is volumetric strain, EL is your longitudinal strain, EC is your circumferential strain. We have find out EL and EC. Okay. So, in this class we have derived here longitudinal strain. In previously we have calculated what? Our hoop strain, longitudinal strain and volumetric strain. But these derivations are not necessary. We generally need the formulas to generate our numericals. So, basically we need to remember all those formulas. Okay. So, until now, till next class, you need to remember those formulas, these formulas. So, in our next class, we will solve some numericals. Thank you.